So when we solve inequalities, we're going to find a solution set that satisfies the inequality. So it's not just going to be x equals, it's going to be x is greater than or x is less than some type of number, and we're going to write it as a set. So on the next page, we'll talk about interval notation and how we'd write an answer. But when we solve an inequality, our answers are going to be solution sets. For this one, when we'd solve, we subtract 1 from both sides. So x is less than 3, kind of similar to how we would solve equations, definitely similar to how you'd solve equations. But from here, we want to write our answer in interval notation. So how would we write this as an interval? What could our answer be between what two numbers? So x is less than 3. What's the largest number that our answer could be? 3. So I'd put a parentheses and 3. What's the smallest number that our answer could be? Negative infinity. Awesome. So we'd write our answer from negative infinity to 3. You always write your interval from smallest to largest. And as a reminder, parentheses always get, infinities always get parentheses. And because it is just a less than also gets a parentheses. If we have less than or greater than, that'd get parentheses. Less than or equal to or greater than or equal to, we're including that number also, so we'd need to put brackets. Next page talks about intervals that are bounded or unbounded. We're not really going to focus on the vocab here, but there may be a couple questions from WebAssign. I think there's a couple in the beginning that ask if they're bounded or unbounded. Unbounded has an infinity in them. So that's how you can tell the difference. Don't stress about vocab for anything other than just getting the questions right on the WebAssign. Same thing with if it's opened or closed. I don't think that there's any on WebAssign about opened or closed, but don't worry about it. Going to example 1. It says write an inequality to represent each interval and state whether the interval is bounded or unbounded. We are going to ignore whether it's bounded or unbounded. We're just going to write an inequality. So it gives us interval notation. These are all in interval notation. Typically, your answer is going to, like when you work out the problem, you'll end up with an inequality. Then you'd need to write your answer in interval notation. So here we're kind of working a little bit backwards, but it's good to know the relation between the two. So for A, we have -3 to 5. So we're talking about x values that are in between -3 and 5 and including 5. How would we write this in interval notation? Awesome. -3 is less than x and? Awesome. And x is less than or equal to 5. Perfect. So since we're talking about numbers in between -3 and 5, we can write it all as one interval. All right, for B, how would we write, we're talking about numbers from -3 to infinity. So what would our x value be? X is what? How would we write it as an inequality? Awesome. You could say -3 is less than x. That works. Or if you wanted to, you could say x is greater than -3. These mean the same thing. I like to write my x first just because I think it's easier to read and understand, but these mean the same thing. These are the same answer. So you can write it either way. No, because saying x is greater than -3, you're talking about everything greater than -3, so you wouldn't put the infinity. How would we write our inequality for C? Awesome. 0 is less than or equal to x, and x is less than or equal to 2. Since we're talking about numbers in between, we can just write it as one inequality. D is a little bit funky because if we saw something that said -infinity to infinity, we'd be talking about all real numbers. If it wants it as an interval, we could just say -infinity is less than x, which is less than infinity. Typically, we wouldn't write this as an interval, but this is how it would be. Awesome. Next, we're going to talk about properties of inequalities. The most important property is the last one here, when you multiply by a constant. If your constant is a positive number, so it says for C is greater than 0, you can just multiply by that number. Nothing happens. Tricky part is when you multiply by a negative. So if C is less than 0, if what your constant is that you're multiplying is negative, you have to flip the sign. So you flip the inequality. So if I had something like negative 4x is greater than 2, how would I solve for x here? Divide by negative 4. Awesome. We have to remember to flip the sign, so we'd say x is less than negative 1/2. So anytime you multiply or divide by a negative, you have to remember to flip the sign. Let's look at example 3. So we're solving for x. We want to get our x's on one side and our constant numbers on the other side. What could we do first here? We definitely could add 3 over 2x to combine the x's. Does anybody have another suggestion of what would make this easier? Yes. Let's multiply everything by 2. You can combine the x's, you'd be adding fractions, that works. You'll end up with the same answer. But to make our lives a little bit easier, let's get rid of that fraction. So let's multiply everything by 2. But don't forget, you have to multiply every single term by 2. Do I need to flip the sign if I multiply everything by 2? No, we keep the inequality the same because it's a positive 2. Only when it's negative, you flip the inequality. So we have 2 minus 3x is greater than or equal to 2x minus 8. Now from here, we can solve for x. I like it when my x is on the left side, but do whatever you want to solve. So I'm going to subtract 2x and subtract 2. So negative 5x is greater than or equal to negative 10. And then I'm going to divide by negative 5. What happens if we divide by negative 5? What do we have to remember to do? Flip the inequality. So we're going to flip it to less than or equal to 2. So x is less than or equal to 2. If we put this on a number line, we'd have a closed circle at 2, and we're talking about x values that are less than. How would we write this as interval notation? From what to what? Awesome. From negative infinity, infinity and negative infinity always get parentheses, to 2 with a bracket. It was less than or equal to, so it gets a bracket. All right, example 4. Here we're solving a double inequality. You can solve it the same way if you want to. If you think that it's easier, you can split it into 2 inequalities. So we have negative 3 is less than or equal to 6x minus 1. If you want to rewrite that as its own thing, and then the other one would be 6x minus 1 is less than 3. You can do that. You can write them separate if you find that helpful. I'm going to keep it together as 1 and just solve it at the same time. So we want x all by itself in the middle. I'm going to add 1, but I have to add it to both sides. So add 1 to the left and add 1 to the right. It's kind of like working with 2 equations at once. You just have 2 inequalities at once. So here we have negative 2 is less than or equal to 6x is less than 4. Then we're going to divide by 6. So negative 1/3 is less than or equal to x, which is less than 2/3. If we put this on a number line, We always start with the smallest number because smaller numbers go to the left on our number line, so negative 1/3 to 2/3. Would negative 1/3 get an open or closed circle? Closed circle, because it's less than or equal to. What about at 2/3? Open circle. X is greater than negative 1/3, so we're talking about values to the right, and x is less than 2/3, so it's going to be in between these two. So when we write this as a interval notation, or write it in interval notation, how would our interval go? Awesome. Bracket negative 1/3 and 2/3 with a parenthesis. Next, we're going to be solving inequalities that have absolute values. So when you have absolute values, if we're solving an equation with absolute values, we get rid of the absolute values by splitting the equation into two, and we'd say equals the number and then equals the negative version of the number. With inequalities, it's a little bit different. It depends on what our inequality is. If we're talking about less than, so if our absolute value is less than a number, we'd keep our inequality the same. We'd say x is less than a, but we also have to include the negative version of it. So we'd say negative a is less than x. So we'd put it all together. So if it's less than, you can think less than is between negative a and a. So less than and kind of go together. If it's greater than, so greater than, we have to be in one inequality or the other one. So we keep the first one the same. We'd say x is greater than a. But for our second inequality, we have to flip it. So then we'd say x is less than negative a. So greater, we have this inequality or the other one. So we've got two. So you always keep the first part the same. The second part depends on your sign. So if you had x is less than a, you keep it as x is less than a. If you have x is greater than a, you keep it as x is greater than a. The second part is what's going to change. So let's do a on the next page. So here we have less than. Less than, we can write it as 1. So we have x minus 5 is less than 2. We keep the first one the same. Where would I put the negative 2 part? Do I have to write it as a separate inequality, or can I write it all together? All together. If it's less than, you write it as 1. So we'd say negative 2 is less than x minus 5. So less than, just write 2 less thans. From here, we can solve for x. So I'm going to add 5 to both sides. So 3 is less than x, which is less than 7. How would we write this in interval notation? Yeah, parentheses 3 and parentheses 7. Perfect. So we're talking about x values in between 3 and 7. Any questions there? For B, it's greater. So greater, we have one or the other one. So we have to write 2 inequalities. The first one stays the same. X plus 3 is greater than or equal to 7. The second one would be x plus 3. We switch the inequality and switch the sign of the number. So it'd be less than or equal to negative 7. Now we just solve both of these inequalities. So I can subtract 3. X is greater than or equal to 4. Same thing, subtract 3 in the other one. X is less than or equal to negative 10. If I put these on the number line, which one would have to come first? Which one goes farther to the left? Negative 10, because it's a smaller number. Would they get open or closed circles? Closed circles, because it's less than or equal to. Now, if x is less than negative 10, are we talking about to the left of negative 10 or to the right of negative 10? To the left. X is less than negative 10. And if x is greater than 4, talking about the right of 4. So how would we write this in interval notation? Does negative 10 get a bracket or parentheses? Bracket, negative 10. Since we have two parts, we need the union. And then what would come next? Bracket 4 to infinity. Awesome. Perfect. So we had to write two separate inequalities here. They don't overlap. We're not talking about numbers in between these two. It's from negative infinity to negative 10 and from 4 to infinity, or from 4 to infinity. So to solve a polynomial inequality, you can use the fact that a polynomial can change signs only at its zeros. So a polynomial can change signs only at its zeros. The x values that make the polynomial equal to 0. Between the two consecutive zeros, a polynomial must be entirely positive or entirely negative. So we're going to find the zeros. Those are going to be our key numbers. And then we have to test the intervals in between the key numbers. Test the intervals. So let's solve example 6. So here we have polynomial inequality. So we can solve this just as if it's equal to. We can pretend it says equal to for now. Because we're going to find the key numbers first. So step 1, find the key numbers. This is just, we're finding the zeros. So the key numbers are these zeros. So we'd solve. What are two factors of negative 6 that add to negative 1? Negative 3 and 2. So x minus 3 and x plus 2. We're just going to say equals 0 for now. So if we set them both equal to 0, what does x equal? 3 and negative 2. Now let's put them on a number line. What would go to the left? Negative 2 comes first, because it's smaller. And what goes to the right? 3, the other number. Would I put open or closed circles at negative 2 and 3? What sign did we start with? Just a less than sign, so we'd put open circles at these points. So our intervals are going to fall in between these key numbers. So either in between or outside. So we have an interval, our first interval would be from negative infinity to negative 2. The second interval would be from negative 2 to 3. And what would our third interval be? From 3 to infinity. Perfect. Now we have to test values to see in which intervals answer this question, which intervals work for a solution for this question. So let's pick a number. We can pick a number on each interval. So let's pick a number inside our first interval. What's a number in between negative infinity and negative 2? Negative 3. Perfect. So we're going to test x is equal to negative 3. These are our test values. You can either plug it into the original question, Or you could plug it into your simplified one, the factored version of it. Just make sure you got the sign right, so this is less than. Either one would work. They're the same equation, they're just written in two different forms. One's factored, the other one's not. I'm going to plug it into the original. So we have -3 squared minus -3 minus 6 is less than 0. So 9 plus 3 minus 6 is less than 0. So 6 is less than 0. Is this true? No. So it does not work in our first interval. Let's try something in the second interval. What's a number in between -2 and 3? 1 is totally works. You can test 1. What's a number that would be a little bit easier to work with the math? 0. Just to make our lives a little bit easier. Pick the easiest numbers you can think of. So 0 falls in between -2 and 3. So 0 squared minus 0 minus 6 would be -6 is less than 0. Is this true? Yes, I'm going to put a check mark there. It works in between in our second interval here. Let's test number 3 also. What's a number that's greater than 3? 4. So let's plug in 4. So 4 squared minus 4 minus 6 is less than 0. This would be 16 minus 10 is less than 0. Is 6 less than 0? Nope, so it doesn't work in this one either. It doesn't work in the third. So our only answer would be the second interval here. So it would just be from -2 to 3. That would be our solution. So the concept of key numbers and test intervals can be extended to rational inequalities. So when we have fractions, we want to do the same thing. We're going to find key numbers. To do this, use the fact that the value of a rational expression can change signs only at its zeros. So the value of a rational expression can change signs only at its zeros. So the zeros of a fraction are when its numerator is 0. So we're looking for where the numerator is 0. But our key points are also going to be at the undefined values. So that is when the denominator is not equal to 0. Because we can't have 0 in the denominator of a fraction. So these are the two things we're looking for our key numbers. Where the numerator is equal to 0 and when the denominator is not equal to 0. We say that it's not equal to 0 because we can't have 0 in the denominator, but it still gives us a key value. So we're going to use it in our interval. So let's look at example 7. When we're solving these types of questions, just like before when we solved with our polynomials, we need 0 on the other side of our inequality sign because we can't just set our numerator equal to 0 when it's 3 on the right side of our inequality. We can't set it just equal to 3. It doesn't work that way. It has to have 0 on the right side of the inequality. So how would we get this to be less than or equal to 0? What should we do? Subtract the 3. Perfect. So we have 2x minus 7 over x minus 5 minus 3 is less than or equal to 0. So now that we have 0 on the right side, that's perfect, but we want it just to be one fraction on the left side. What do I need if I'm subtracting a fraction and a whole number? We need the same denominator. We need a common denominator. So I'm going to put 3 over 1. What does the denominator of 3 over 1 have to be? What's our greatest common denominator here? X minus 5. Perfect. So we're going to multiply the top and the bottom by x minus 5. So here we have 2x minus 7 minus 3x plus 15 over x minus 5. I'm going to simplify this, just combine our like terms, so negative x plus 8 over x minus 5 is less than or equal to 0. Awesome. So now we need to find our key numbers. Our key numbers, we set the numerator equal to 0 and the denominator not equal to 0. So the first one, we have negative x plus 8 equals 0. What does x equal? X equals 8. And the second one, x minus 5 does not equal 0. What does x not equal? 5. So let's put those on our number line. Which one goes to the left? Which one do I put on the number line first? 5, because it's a smaller number. And then 8. So now I got to think about it for a second. Can 5 be an answer choice? No, why not? It makes the denominator undefined. So do I put an open or closed circle at 5? Open circle. Can 8 be an answer choice? What was my original inequality? Less than or equal to. So 8 can be an answer choice, so we put a closed circle there. So now our intervals that we're going to test, we've got 1, 2, and 3. So we have from negative infinity to 5, from 5 to 8 with a bracket, and bracket 8 to infinity. What's a number that we can test in our first interval? 4 works. You can totally test 4. What's easier than 4? 0. 0's in our first interval. So that would always be my recommendation. Now we can plug it into the first inequality. So our original equation, we could plug it into our simplified one here, where it's less than or equal to 0. This would be my recommendation, just because I think it's going to be easier to tell if it's less than or equal to 0 versus less than or equal to 3. But either one will work. It'll give you the same answer. So I'm going to plug it into the second one here. So 0 plus 8 over 0 minus 5 would be 8 over negative 5. Is this less than or equal to 0? Yes. So it works here. So it works in our first one. What's a number in between 5 and 8 that we can test? 6. So we have negative 6 plus 8 over 6 minus 5. So that would be 2 over 1. Is 2 less than or equal to 0? No, does not work in our second interval. What's a number in our third interval that we can test? Sure, let's plug in 9. You can plug in 9, 10, 11, 12, whatever you want. 9's a good one because it's closest to 8, so it's going to be the smallest number that we can plug in. So we have negative 9 plus 8 over 9 minus 5. So this would be negative 1 over 4. Is negative 1/4 less than or equal to 0? Yep. So does our third interval work? Yeah. So what worked is our answer. So we have negative infinity to 5 and 8 to infinity. Bracket 8 to infinity. So that would be our answer. Let's look at example 8. We want to find the domain. What can we not have under a square root? A negative number. So what does whatever's under my square root have to be? So if we said what's under the square root can't be negative, how would I write that in math terms? If it was negative, it'd be imaginary. But I'm saying mathematically, this has to be, it has to be what? It has to be positive, has to be greater than, what number? This has to be greater than or equal to 0. So we're just talking about the whole thing. Whatever's under our radical has to be greater than or equal to 0. Because it's got to be positive. This is how we say it's a positive number. Positive number or 0. So 64 minus 4x squared is greater than or equal to 0. We're going to solve this just like we did before with our polynomials. So we got to find our key numbers. What should we do first to solve? We totally can. But to make our lives a little bit easier, what else could we do? Divide everything by 4. When you have a GCF that is a constant number, just get rid of it. Make all your numbers smaller. Make our lives easier. So we have 16 minus x squared is greater than or equal to 0. What could we do next? Definitely can, and you'll get the same answer. But what else could we do? What is it? Difference of squares. We can factor this. What does it factor into? Careful. Let's look at it again. 4 plus x and 4 minus x. This is different than x plus 4 times x minus 4. Signs are different. The x comes second, so the x has to come second in our parentheses. So we're just going to say that it's equal to 0 for now because we're solving to find our key points. So when we set them both equal to 0, x equals what? Negative 4 and positive 4. Which I guess if you said x plus 4 and x minus 4, you'd end up with the same thing, but that's just lucky. Your work would be wrong. So these are our key points. Let's put them on a number line. We've got negative 4 and positive 4. Would they have open or closed circles? What do we think? Raise your hand if you think open. Raise your hand if you think closed. Raise your hand if you're lost. Okay. It is greater than or equal to, so let's think about it again. Greater than or equal to would have open or closed circles? Closed circles. So we have a closed circle at negative 4 and 4. Now we want to test the intervals. So we have interval 1, 2, and 3. Our first interval, how would we write it in interval notation? Negative infinity to negative 4 with a bracket. What about the second interval? Negative 4 to positive 4 with brackets. And our third interval? Bracket 4 to infinity. All right, let's test values. So we can plug it in. You can plug it into the simplified version here, which would be my recommendation. You could plug it into the 64 minus 4x squared. That would work too. Or you could plug it into the factored form if you had your inequality in it. So if this was still less than or equal to. Either way works. I'm going to plug it into this one. The 16 minus x squared is greater than 0. I just think that's going to be the easiest one to work with. What's a number in our first interval that we can test? Negative 5. So we're going to test negative 5. We've got 16 minus negative 5 squared is greater than or equal to 0. 16 minus 25 is greater than or equal to 0. Negative 9 is greater than or equal to 0. Does this work? No. So interval 1 does not work. Let's try interval 2. What's a number in interval 2 that we can test? 0. So let's plug it in. 16 minus 0 squared is greater than or equal to 0. 16 is greater than or equal to 0. Is this true? Yes. So it works in the second interval. Let's just try the third one just to be super sure. What's a number greater than 4? 5. So 16 minus 5 squared is greater than or equal to 0. 16 minus 25, which would be negative 9. Is negative 9 greater than or equal to 0? Nope, does not work in that one. So it only works in our middle interval. So how would we write that in interval notation? It's right here. Negative 4 to 4. Awesome, that would be our answer. The one that I think kind of looks a little challenging is it asks you to find the domain of something like, let's just say, if it was x minus 3 over x plus 5. It's a little bit different numbers on the homework, a little bit more work, but something like this. How would we find the domain here? What would we do? We're finding the domain. What can we not have under the square root? Negatives. So we have to set whatever's under our square root, what? Greater than or equal to 0. So we'd say x minus 3 over x plus 5 is greater than or equal to 0. What do we do from here? Awesome. We want to find our key points. So we set the top equal to 0 and we set the bottom not equal to 0. Find your key points on your number line. Test your intervals. So I thought this was a good question because it kind of involved both things that we did.